tapos na kayo magsagot ng ating evaluation exam because now we will discuss the answers in your physical chemistry evaluation exam. So again, this is 80 items of phychem questions, okay? And you were given 150 minutes to answer. So I hope guys, okay, na sinagot niyo talaga to in just 150 minutes, okay? Ayan. So, recap lang ng mga topics, okay, involved in physical chemistry. So here we have quantum mechanics, okay? Dito sa leftmost column, guys, is the topic name, okay? And then the corresponding items per topic. So for items 1 to 7, okay, these are quantum mechanics questions. For questions 8 to 16, these are thermodynamics 1 questions, and so on and so forth. Okay? So for quantum mechanics, guys, you have 7 items. For thermo 1, you have 9 items, and so on and so forth. So guys, let's start with quantum mechanics, okay? Ayan. So for the first question, in the Schrödinger equation, the quantity H hat Hamiltonian represents the A, wave function of the system, B, probability density, C, momentum operator, or D, total energy operator. Ano kaya ang sagot, guys? Okay, so recall guys that the Hamiltonian operator H hat describes the total energy of a particle or a system. Okay, so for a one-dimensional system, again guys, this is your Hamiltonian operator, yung naka-blue, where the Hamiltonian H hat is just equal to the kinetic energy operator plus the potential energy operator. Okay, guys, dapat memorize nyo ang form ng ating Hamiltonian operator. Okay, negative h bar square over 2m times the second derivative, okay, of x times the wave function plus bx. Okay, so again, the answer for number 1 is just letter D. Very easy, right? Okay, next, let's go to number 2. Ayan guys, so possible na ganito yung mga types of questions sa board exam. So for number 2, which is true if the wave function is normalized? Okay, so we are given here 4 different types of equations. Ano kayang sagot, guys? Recall that for normalization, okay, again, the wave function is normalized by multiplying it to a certain normalization constant n to ensure that the total probability of finding the particle between positions A and B is equal to 1. So this is the condition, guys, diba? Wave function times wave function dx, okay, get the integral from A to B that is equal to 1. So guys, again, kapag wala kang imaginary numbers sa inyong wave function, then this expression here is just wave function squared dx equal to 1. Tama? Again, if for example, wala kang imaginary numbers sa inyong wave function, syempre hindi mo na kailangan kunin ang complex conjugate. So for number 2, guys, the answer is letter D. Okay? Oh, bakit mali yung iba? Syempre, guys, that does not describe normalization. Okay, look at letter B, guys. Letter B. Okay, equal to 0, mali yan agad, diba? Okay, again, dapat integral of wave function times wave function equal to 1. Again, wave function asterisk is the complex conjugate of your wave function, okay? Next, number 3. Ayan. Determine the eigenvalue of the momentum operator, P x hat, is equal to I h hat, derivative of x with eigenfunction e to the power I k x. Okay, guys, so may correction tayo dito. Pero guys, dapat at this point, memorize nyo na ang momentum operator. Okay, so guys, you know that for the momentum operator, it is equal to negative I h hat times delta over delta x, diba? This is the derivative operator. Tama? First derivative operator. Again, guys, ito ang tamang momentum operator. Dapat may negative to. Okay, so dapat alam nyo na yan, ha? Dapat memorize natin yan. Okay? So, guys, ito yung gagamitin natin, ha? Negative I h hat. So, okay, ang gagawin natin is, again, operate on the wave function. Diba? Tapos makukuha lang natin ang eigenvalue, guys, if let's say, let's operate on the wave function. Tapos, alright, makukuha natin ulit ang same wave function multiplied by a certain constant A. Again, the certain constant A here is what we call the eigenvalue. Okay, so let's answer, guys. Let's operate on the wave function using the momentum operator. So, your wave function is e to the power of I k x times the momentum operator here. Okay, guys. So what is the derivative of e to the power of I k x? Oh, e to the power of x muna. The derivative of e to the power of x is e to the power of x. Tama? Now, use chain rule. Okay, guys, you have to apply the chain rule. So we have to find the derivative of I k x. So the derivative of I k x is, syempre guys, that is equal to I k. Tama? Because I k are constants. Okay? So the function will become, after derivation, guys, your whole expression here will become negative I squared times h bar k times e to the power of I k x. Okay? Well, guys, recall from your mathematics, I squared is just equal to negative 1. Tama? The square of the imaginary number is just equal to 1. So let's substitute that. So negative times negative 1. Again, this is your I squared times h bar k times e to the power of I k x. Ayan. So kayang-kaya na natin makita ang ating wave function. Tama? Again, this is your wave function. So basically, guys, ito ang whole expression natin. Okay? Ayan. Okay. So again, this is your operator here. This is your wave function. And then on the right side, we got the same wave function back, e to the power of I k x. And your eigenvalue is h bar k. So the answer is letter C. Claro, guys? I hope that's clear, ma'am. What if ginamit ko talaga yung positive IH bar sa ating momentum operator so hindi kinaglagay ng negative? Guys, ang magiging sagot dito ay negative H bar K. So, among our choices, sino kaya ang closest dyan? Siyempre, si letter C pa rin. Claro, guys? I hope that's clear. Okay, let's proceed. Again, you have to memorize our Hermitian operators, the various Hermitian operators. As much as possible, guys, kung ano yung kaya natin i-memorize, maximize natin. Okay? Kasi siyempre, guys, hindi tayo sure kung ano yung lalabas sa board exam. Tama? Okay. Take note, guys. What does H bar mean? Again, H bar is just equal to H, the Planck's constant, divided by 2 pi. Okay? Next. Number 4, which of the following is stated in the first postulate of quantum mechanics? A, a wave function specifies the state of a quantum mechanical system. B, a wave function can be described using a spatial variable. C, a wave function can be described using a time variable. D, all of the above. So guys, answer is all of the above. Again, all of these choices, A, C, B, C, C, describes the wave function, which is the first postulate of quantum mechanics. Okay? So A, guys, diba sabi dito, wave function specifies the state of a quantum mechanical system. That is the very definition of your first postulate, which describes the wave function, right? Next, letter B, sabi dito, a wave function can be described using a spatial variable. Yes, and we know that, right? Because for a particle in space, the wave function depends on position, diba? So for example, for a one-dimensional system, okay, the position is x. Pero if you have a three-dimensional system, you have coordinates x, y, z. Next, letter C is also true, diba? So for time-dependent, okay, the wave function also evolves with time, according to the time-dependent Schrödinger equation. Therefore, letter D is true. Okay? Next, number 5. Yan. A harmonic oscillator is used as a model for A, molecular rotation, B, the hydrogen atom, C, electronic transitions, or D, molecular vibrations. So guys, ano kayang sagot dyan? Okay, guys, mali na agad si letter A, tama? For molecular rotation, this is described by rigid rotor model, tama? Hydrogen atom, mali din, di ba? Electronic transitions, mali din, di ba? Recall, guys, ang electronic transitions natin, ganito yung mukha, tama? Ganito ang energy levels. Tandaan niyo pa ba, guys, sa ating in-org, di ba? Example, this is n is equal to 1, this is n is equal to 2, tapos n is equal to 3, pataas, di ba? Palapit ng palapit ang energy gap, di ba? Between the energy levels. So, again, guys, recall, for a harmonic oscillator, you have vibrations, right? Where the energy levels are equally spaced. So, the answer for letter number 5 is letter E. Okay, again, letter A is false because the molecular rotation is modeled using rigid rotor. B is also false, okay? So in the hydrogen atom, guys, minamodel natin using the column potential, di ba? Bakit column potential? So recall the Schrodinger equation of your hydrogen atom, di ba? You have here a kinetic energy term and potential energy term. So the potential energy term here describes the attraction between the electron and the proton in your hydrogen atom. Next, for letter C, also false, okay? Pag electronic transitions, guys, di ba? You have unequally spaced energy levels, di ba? Ito yung mga energy levels in your atoms and molecules. So lastly, for letter D, okay, this is exactly what the harmonic oscillator models, okay? I hope that's clear, guys. Kayang-kaya, diba? Okay, number 6. What is the wavelength emitted in the Lyman series if an electron from the third level loses that energy? Okay, guys, so these are the choices. Okay, so guys, hindi nyo kailangan ng dapat memorize talaga ang Lyman series. Gets ba? Kailangan natin solve ito using the Rydberg equation shown here. Okay? Okay, so for the Lyman series, guys, diba? From a higher energy level, sabi dito from the third level, magdadrop siya to the n is equal to 1 energy level. And then, guys, the n here refers to the final energy level n, diba? From n is equal to 3 to n is equal to 1. So, recall nyo lang, guys, si Lambda of the Philippines, beta fun ha. Okay, again, so let's use the Rydberg equation. 1 over wavelength is equal to the Rydberg constant, okay, times 1 over n1 squared minus 1 over n2 squared. Recall, guys, n1 is less than n2, tama? Where n1 is equal to 1, ba ito yung ending Lyman series, n2 is equal to 3, which is given here. So, substituting, guys, 1 over lambda is equal to Rydberg's constant. Again, this is just shift, convert, 16 times 1 over 1 squared minus 1 over 3 squared. Okay. Guys, mahirap tayo shift. So, ang gagawin nyo, hanapin nyo muna si 1 over wavelength. Okay, so to get 1 over wavelength, ayan. 1 over wavelength is equal to 9754428.06. Okay, so inverse na natin, guys. Therefore, the wavelength is equal to 1.025 times 10 to the negative 7 meters. Now, kailangan natin in terms of nanometers ang ating answer, diba? So, convert meters to nanometers, guys. Tandaan. Okay, 1 nanometer is just equal to 1 times 10 to the power of negative 9 meters. So, solving, we get 102.5 nanometers. O, sinong closest dyan? Siyempre, si letter A. I hope that's clear, guys. Diba? Kaya, right? Okay, next. Number 7. Oh, familiar. Familiar ba? Okay. A fluorescent dye absorbs a photon of light of 485 nanometers and emits a photon of light of 540 nanometers. How much energy in joules is lost as heat? Okay, so these are the choices, guys. Okay, so in order to answer this question, again, we must use, okay, the energy equation sa in-order pa to, guys, diba? So, hahanapin natin, guys, ang energy absorbed and then the energy emitted. Okay, para mahanap natin yung energy lost as heat. Klaro, guys? Kasi syempre, guys, hindi lahat ng na-absorb na energy, diba? Hindi lahat yan may emit, tama? Okay, so to get the energy lost as heat, basically, guys, energy absorbed minus energy emitted. Okay, so let's get the energy absorbed, that is equal to h, the Planck's constant 6, tama, times the speed of light, 3 times 10 to the power 8 meters per second, divided by the wavelength, which is given. So sabi dito, the fluorescent dye absorbs a photon of light at this wavelength here. So 485 nanometers convert to meters. Okay, so solving, we get E absorbed is equal to 4.10 times 10 to the negative 90 joules. So now let's get the energy emitted, that is equal to h times c over the wavelength given, 540, then convert to meters. Solving, we get 3.68 times 10 to the negative 19 joules. Okay, again, the energy lost as heat is just energy absorbed minus the energy emitted. Okay. So 4.10 times 10 to the negative 19 minus 3.68 times 10 to the negative 19. Guys, ha? Ulit-ulitin ko na to. Again, when solving this in a calculator, tandaan, the importante ang parenthesis. So solving the energy loss as heat, we get 4.17 times 10 to the negative 20. Letter A. Ayan. Now we are done with our quantum mechanics questions. What do you think, guys? Kayang-kaya, diba? Okay, now let's move on to thermodynamics part 1. Or recall, guys, we discussed here the basic concepts of thermodynamics, the first law of thermodynamics, and thermochemistry. So in this topic, guys, we have 9 items on our eval exam. Okay, so makinig. Number 8, which of the following is a state function? Kayang-kaya, guys, diba? Okay. So A gives free energy, B Helmholtz free energy, C internal energy, D all of the above. So syempre, guys, okay, all of the above, diba? Okay, all of these are state functions. Or recall, guys, these are your state functions, diba? Pag sinabi natin state functions, we are only concerned on the initial state and final state of your system and not on the path taken by your system in order to reach the state. Whereas for path functions, we are concerned with the path taken. So for example, ang path function, work and heat, diba? Okay. Ayan, next number 9. For a constant pressure process, what is the difference between the internal energy change and the enthalpy change? So this is conceptual, guys. Okay, nasagot ba to? Okay. So guys, in order to answer this question, kailangan natin i-manipulate yung mga equations na alam natin. Ma'am, saan ba ako mag-start? Hindi ko alam saan ako mag-start. Okay, guys, mag-start tayo sa pinaka-basic na enthalpy equation. Okay, again, start with the most basic enthalpy equation. Recall, guys, this equation here is your general equation for enthalpy. H is equal to U plus PV. O, kita nyo, guys, meron ka na agad relation ng H and U in this equation here. Okay, so the definition of enthalpy again is H is equal to U plus PV. If we get the change, that is just delta H is equal to delta U plus the change in P and V. Now, guys, sabi dito, we have a constant pressure process. Tama? Tama? So, in other words, guys, this is just DH is equal to DU plus PdV plus dVP. Tama? Okay, so if you have a constant pressure process, guys, then this is equal to 0, okay? Because dP is equal to 0 in this process, okay? So, matitira na lang sa inyong equation ay delta H, dH is equal to du plus PdV. So, same lang ito, guys, ha? Okay? Ayan. Now, let's rearrange. Bakit? Kasi kailangan natin makita ang difference between the internal energy change and the enthalpy change, right? So, rearranging, delta H minus delta U is just equal to P delta V. O, familiar na ba si P delta V? Oh, guys, recall, work is equal to negative PdV. Diba? Diba, guys? So, this is related to PV work at constant pressure. So, ang tamang sagot, syempre, C, work. Klaro ba, guys? Klaro ba? Then, the correct answer is work. Okay, so work, guys, this is the extra energy used to expand the system. Literally, pressure, volume, work. Bakit pressure, volume? You have pressure, tapos you have change in volume. Okay? Ma'am, bakit iba, yung mga iba mali? Okay, first, guys, CA, heat, which is Q, that is wrong, di ba? Okay? So, heat at constant pressure, guys, again, heat at constant pressure, again, is just equal to delta H, tama? Okay? So, not delta H minus delta U. Again, guys, hinahanap natin the difference between the internal energy change and enthalpy change. Next, guys, entropy is also wrong. So, entropy hindi siya connected, di ba? Entropy is about disorder, not energy difference. Okay? Lastly, for letters B, guys, ayan, ibang definition ni Agatas, di ba? It is totally unrelated to U. Bakit? Recall your definition for Gibbs free energy, delta G is equal to delta H minus T delta S. So, hindi siya ma-relate sa delta U in this case. Okay? So, the answer again is letter B. Kasi makikita nyo ito, guys. Work, diba, is just equal to negative PdV. But from here, makukuha nyo ito, guys. Gets? Okay. Next, number 10. Okay, oh guys, familiar pa ba? I hope so. Okay, so guys, this is a previous board exam question which is true about a gas that is compressed isothermally. Okay, so guys, again, for an isothermal compression, diba, the surroundings is doing work on the system. So if the surroundings is doing work on the system, work is positive. Therefore, work is greater than zero. And this is proven by compression. Now guys, ano bang isa pang clue? We have here isothermal process, or recall, for any ideal gas, okay, assume agad guys, ideal gas to, diba? Delta U is equal to zero. Tama? Diba? For an isothermal process, right? Bakit? Again, recall the general equation for du that is equal to CVdt plus pi t dv, right? Again, for any ideal gas, pi t is equal to zero, so this is zero. Tama? And for an isothermal process, dt is equal to zero, so this is zero. Therefore, du is equal to zero. Since du is equal to zero, okay, or recall, your equation for your internal energy is Q plus W. So if zero is equal to Q plus W, therefore, Q is just equal to negative W. We know, guys, that work is greater than zero. Therefore, Q is just less than zero. Gets, guys? Okay, that's why the answer is letter T. Okay? Ayan, so recall lang this one, guys. Okay, again, Q is equal to negative of work. Okay? Ayan, next number 11, a 0.5 mole of gas at 300 Kelvin expands isothermally from 2 liters to 6 liters. What is the maximum work associated with the process? Okay, so context clues, keywords muna, keywords, okay? Isothermal expansion, okay? 0.5 mole of gas. So guys, mag-assume na tayo ng reversible process. Bakit wala namang sinabing irreversible, guys, diba? Wala namang sinabi na rapid expansion. Gets ba? So again, in this case, let's assume reversible isothermal expansion, and these are the given values. Temperature is equal to 300 Kelvin. The initial volume 2 liters, final volume 6 liters. Work is yun yung hinahanap natin. So ang gagamitin equation for a reversible isothermal expansion, guys, keyword reversible isothermal expansion, ito, okay? Work is equal to negative nRT ln V2 over V1. Ma'am, what if irreversible siya? Eh, di ito yung gagamitin natin. Klaro, guys? Okay? Where P here is usually the external pressure. Wala kang mga external pressure dito, guys. Tama? Okay, so that's why gagamitin natin ang work for an isothermal reversible process equation. So work is equal to negative nRT ln V2 over V1. Okay? So substitute lang, guys. Ayan. Work is equal to negative 0.5 times R times 300K times ln 6 over 2. Okay? Solving, we get negative 1370 joules. Now, guys, negative sign indicates that the work is done by the system, which is the gas, right? But the question asks for magnitude. Bakit magnitude hiningi? Sabi dito, what is the maximum work associated with the process? Oh, ano yung process, guys? Expansion, right? In expansion, work is being done by the system. So, anong ginagawa ng work? Anong work ang ginagawa ng system nyo? So, ang magnitude yan is 1370 joules. Okay? Ma'am, what if what is the work done by the gas? O what if hindi ito yung tanong? Hindi what is the maximum work associated with the process? What is the work done by the gas? So yung tamang sagot is negative 1370 joules. Gets? Okay? So pag, guys, in this case, tinanong sa atin, what is the maximum work or the magnitude of work? Tinatanong sa atin, yung amount lang, yung magnitude lang, walang sign. Okay? Direction is not needed. That's why 1370 joules is the answer. Okay? Okay. Next, number 12. Ayan. Which reaction below is the most likely to be endothermic? Okay. So guys, pag sinabing endothermic, di ba? Yung inyong system, di ba? Yung inyong reactant absorb heat. Okay. So the answer, guys, is letter A, di ba? Bakit endothermic yan? Ano nangyari kay magnesium? It's sublimed, di ba? Solid magnesium, di ba? It turned into vapor. Or recall, guys, in order to sublimation to occur, you have to absorb heat, di ba? So your magnesium here has to absorb heat, in order for it to have a more disordered state, tama? Which is a gas state. Okay? So bakit kailangan endothermic reaction? Kailangan mag-absorb heat, guys, to break the intermolecular forces between the solid magnesium molecules. Okay? Okay? Kaya guys, okay, therefore endothermic si letter A. Next, what about letter B? Okay, so guys, in your reactant side, you have here gaseous sodium and gaseous chloride and ion. Tapos that forms solid sodium chloride, di ba? So meron kang gas to solid deposition. Oh guys, this formation here of a solid releases a lot of energy. Bakit? Kung nag-combine si NaCl to form NaCl, a solid, right? So that requires a release of energy. When you release energy, you release heat, right? And for a release of heat, you have an exothermic reaction. Okay? I hope that's clear, guys. Now, what can we say about the delta S for letter B? Delta S decreases in this case, tama? Because from gas to solid. Or recall, guys, lower entropy ng solid, diba? That's why for letter B, entropy decreases. For letter E naman, entropy increases. Next, like letter C. Okay? So you have here sodium, okay, plus an electron forms sodium, also a gas. Okay? So you have reduction, diba? Sodium gained an electron. Okay? So usually, guys, this is an exothermic process. Okay? Okay? So, pero guys, for Na+, para ma-reduce to Na, meron kang positive electron affinity. Or recall, guys, definition of electron affinity, diba? For a gaseous atom, for example, si sodium, but you will add another electron to it, diba? Diba? So, si sodium, okay, mag-gain siya ng another electron. Okay, so you have a positive electron affinity. Okay, so since sodium has a positive electron affinity, ma'am, bakit may positive electron affinity? Recall, guys, your periodic trends, right? Diba? Ang ating trend for electron affinity is increasing across a period, diba? Tapos decreasing down a group, right? Okay, so we know, guys, na compared to our P block elements, diba, si sodium, it has a more positive electron affinity. So if it has a positive electron affinity, okay, it needs energy in order to gain an electron. Okay, so it is possibly endothermic. Okay, again, letter C is possibly endothermic or slightly endothermic. Pero guys, si A pa rin yung tamang sagot kasi siya yung most likely. Pero si letter C, slightly lang or possibly lang. Okay? So A, guys, again, sure ka na endothermic yan, di ba? Okay, lastly, for letter D, guys. Okay, for letter D, this is an exothermic process. Okay, in this case, you have a neutralization reaction. Okay, so a neutralization reaction is always exothermic. Recall, guys, pag neutralization, okay, when combines H plus and OH minus to form H2O, okay, when they combine, that releases heat. Okay? Yeah, so this is exothermic. Now, what can we say about the delta S for letter D, for the change in entropy for letter D? So delta S for letter D is negative. Bakit? The combination of the two ions, okay, form a more ordered liquid, which is water. Okay, that's why delta S for letter D is negative. Okay? Okay, I hope that's clear, guys. And again, for number 12, the answer is letter A. Ayan, number 13. O, diba? Binigyan ko kayo ng formula nito, guys. Well, let's try. A 100 grams copper metal, okay, with a specific heat capacity of 0.385 joules over gram times degree at 50 degrees Celsius is dropped in 100 ml of water at 25 degrees Celsius. What is the final temperature of the mixture? Oh, guys, ano kaya sagot nyo? Okay, tayo mo natin sagutan. So we are given here a copper metal with a mass of 100 grams, initial temperature of 50 degrees Celsius. Okay, and then we're also given here water with a mass of 100 grams. O, bakit yung ginawang 100 grams? Diba, guys, ang density ng water is just 1 gram per ml. So, 100 ml of water is just equal to 100 grams of water. Then the T2, the initial temperature of the water is equal to 25 degrees Celsius. Ayan. So guys, in this case, ilalagay nyo si metal sa water. Tandaan guys, si copper metal, hindi yan mag-melt in water. Okay? So wala kang phase change. Only temperature change. Klaro guys? Again, wala kang phase change in your copper and in your water. Okay? So guys, to solve this one, the heat of the metal is equal to the heat of water. Okay? Ma'am, bakit ganon? Okay guys, pag inad nyo kasi yung metal na yan sa water, di ba at first mainit siya. Pero dinagdag mo siya sa tubig na mas malamig. So guys, anong mangyayari sa copper metal mo? Lalamig or init? So syempre guys, kung nilagay nyo siya sa mas malamig na water, edi lalamig si copper metal as you mix it with water. Klaro guys, as you submerge it in water. What happens naman kay water? In this case guys, for water, okay, minix mo siya with a hotter copper metal. Tingnan nyo guys, higher ang temperature ni copper metal. Okay? So for water guys, iinit yan. Mag-increase ang final temperature niya. So let's get the MC path. Diba? Again guys, Q is equal to MC path. Tama? So let's get the MC path for each equation guys. Q metal is equal to M1 times Cp times T1 minus F. Ma'am, bakit nauna si T1? Bakit nauna ang initial temperature ni copper metal? Again guys, mas mainit ang copper metal than the water. So your copper metal guys will lose heat. Tama? Upon submerging it in water. Gets? Tapos yung heat lost by the metal is equal to the heat gained by your water. Again guys, kasi mas malamig ang tubig nyo. Again, just look at the temperatures. Okay? So in this case guys, we would expect that the final temperature of your copper metal is lower than its initial temperature because again, it lost heat. That's why ang lalagay natin T1 minus Tf. That is equal to Q of water. Q water is equal to M2 times Cp. So guys, the Cp here is the specific heat capacity of water times Tf minus T2. Ma'am, bakit nauna si Tf dito? Again guys, diba ang final temperature ng inyong water will now be higher, right? Upon submerging the copper metal in your water. Again guys, kasi mas malamig si tubig. So mag-gain siya ng heat from the copper metal. Okay? Tf minus T2. Ma'am, bakit nga ulit? Bakit hindi ito yung ginawa nyo? Guys, pwede nyo naman ito gawin. Okay? Kaso nga lang guys, mas madali ito, diba? Diba? Mas straightforward siya. So guys, pag ito yung ginamit nyo guys, ang kailangan nyo gawin is M1 Cp Tf minus T1 tapos plus M2 Cp Tf minus T2. Again, pag ginawa nyo to, makukuha nyo yung same answer. Okay? Pero guys, if for example, meron ka lang temperature change, again, mas magandang i-equate nyo na lang. Okay? Ma'am, kailan ko gagamitin yung equal to 0? Guys, mas magandang gamitin yung equal to 0 when you have phase changes in the mixture. Okay? If guys, for example, yung ginagawa natin dati, diba? Ice plus water, diba? Ine-equate natin to 0. Diba? Kasi mas madaling i-solve in that case. Okay? But in this case, guys, you only have a temperature change. Okay? You only have sensible heat. That's why, i-equate na lang natin silang dalawa. Okay? Tapos ito yung form ng equations nila. Okay? Ayan. So, substitute lang natin lahat ng alam natin na equations ay na values. So, M1 is 100 grams for the copper metal times Cp 0.385. Okay? Again, it's specific to your copper metal. Okay? This is in terms of joules, guys. Diba? Joules over grams times degree Celsius times 50. This is the initial temperature of your metal minus Tf is equal to 100 grams of water times 4.18. So guys, the specific heat capacity of liquid water, diba, is equal to 1 cal, diba, over grams times degree Celsius, right? Pero guys, gusto natin in terms of joules. Bakit in terms of joules? Kasi yung specific heat capacity natin for your copper metal is in terms of joules. So convert natin to ito into joules. So this is equal to 4.18 joules over grams times degree Celsius. Okay? Times Tf minus 25, also given. So shift solve lang guys and you will get the answer. Tf is equal to 27.1 degrees Celsius. Letter A. Again guys ha, pag minix mong copper metal in water, wala kang phase change. So better guys, equate na lang sa dalawa para mas madaling solve. Okay? Next, number 14, which of the following describes the Joule-Thomson experiment? Okay? It's the answer, guys. Halata naman, di ba? Okay, so recall your Joule-Thomson experiment. You have here a Joule-Thomson apparatus. Ang nangyayari, guys, is the real gas. It goes from a high pressure region to a low pressure region. So, what happens, guys, is you decrease the pressure of your real gas. When you decrease the pressure of your real gas, your gas will expand. Okay? In the throttling process. Ang pag sinabi natin throttling process, guys, dadaan ang real gas in a narrow constriction. Ang narrow constriction na yan ay ang porous plug dito. Okay? Again, ang narrow constriction na yan ay ang porous plug dito. Yan ang tinatawag na throttling process. Ma'am, bakit adiabatic? Because you have here insulated walls, so there is no heat exchange between the system here, okay, and the surroundings. Okay? So you have letter B, throttled adiabatic expansion. Okay? Okay guys, bakit mali sa letter A? Guys, hindi naman isentropic ang ating Joule-Thomson experiment, ba? Okay? Again guys, pag isentropic, meaning yan constant ang entropy. Okay? Next, pag adiabatic compression, mali din. Alam natin guys na mag-expand talaga ang real gas. Okay? Okay? And lastly, isothermal expansion, mali din yan. Alam natin guys na upon the expansion of your real gas in the Joule-Thomson apparatus, diba? The real gas will either cool or warm, diba? So the real gas will either cool upon expansion or warm upon expansion. Okay, next. Ayan. Kaya ba to guys? Ayan. Number 15, delta E unit is equal to delta E system plus delta E surroundings, which is equal to 0. And this can also be stated as, ano kayang sagot guys? Again guys, recall, in some other references, delta U is just delta E. Okay? So guys, sabi dito, the delta E of the universe is equal to 0. Okay? So, sino kaya magsasabi nito? Any guess? Guys, tingnan muna natin isa-isa. For letter A, no. Bakit? Because this is the definition of enthalpy. Walang connect sa equation natin dito. Next, letter B, also no. Because the equation here relates enthalpy change to temperature change, diba? So guys, dapat small n to guys, small n yan. Okay? Again, delta H is equal to NC path. That relates enthalpy change to temperature change. Next, letter C, also no. O si agatas yan guys. Si agatas, diba? Gibbs free energy. Iba ang definition yan. Diba? Gibbs free energy is the maximum usable energy. Diba? Usable energy. Diba? Ng inyong system. Okay? Or in other words, delta G also displays spontaneity of reaction. Wala siyang connect sa ating first law of thermodynamics. You know guys, for letter D, it is the correct answer. Delta E is equal to Q plus W. So that is just the same as delta U is equal to Q plus W. Because this directly expresses the first law. Okay? So consistent guys, ang dalawang yan. Okay? Yung dalawang yan guys shows us that the total energy of the universe is conserved. Claro? Okay, for example, ang internal energy, it is conserved. Diba? It is conserved because it is either transformed in the form of heat or in the form of work. Okay, therefore, for number 15, the answer is letter B. Okay, so again, guys, recall this statement here, this expression here shows us that the total energy change of the universe is 0, which defines the first law of thermodynamics for an isolated systems. Okay, so it also indicates, guys, that for an isolated system, energy is conserved. Okay, I hope that's guys. Ayan. So, ano bang meaning talaga nito? Okay, so basically, guys, yung energy lost by the surroundings plus energy gained by the system is just equal to 0, diba? So yung energy na yan can be absorbed as heat or lost as work, diba? Or ginawa mong work, diba? Okay. And that's why, guys, this equation here shows us that energy is conserved. Okay, ayan. Natatransfer lang yung energy na yan in the form of heat and work. Okay. Next, guys, number 16. Which of the following is true about the complete combustion of methane? Oh. Okay, so we are given these choices here. Okay, so we are given here the standard enthalpy of combustion equal to negative 890.3 kilojoules per mole. Okay, guys, review lang. Anong meaning kapag may not? Okay, this is the standard enthalpy of combustion. Tama? So this is the enthalpy of combustion in standard conditions. Anong meaning ng standard conditions? Guys, iba ang standard conditions sa STP. Okay? Pag sinabi natin standard conditions, guys, ito yung measurement ng enthalpy of combustion nyo, or for example, delta S or other properties in standard conditions, meaning at 25 degrees Celsius. Pag sinabi natin STP, guys, iba yan. So for example, di ba sa gases, hinahanap natin, for example, volume ng gas at STP, pressure ng gas at STP. Gets ba? Pag sinabi natin STP, iba yan. The temperature is 273 Kelvin, di ba? Pressure is 1 bar. And for every 1 mole of gas at STP, they occupy 22.4 liters of volume. Okay? So tandaan, guys. Again, iba ang STP sa standard conditions. Okay? Sa standard conditions, guys, doon mini-measure ang enthalpy of combustion. Kaya meron tayo tinatawag na standard enthalpy of combustion. Okay? Ayan, so let's examine every choice, guys. So ang sagot dito is letter B. Okay, so let's examine, guys. Ayan. So for statement A, sabi, a gram of methane requires 890 kilojoules of heat to burn completely. Una sa lahat, guys, heat is released. Not required, kaya mali agad yan. And next also, guys, a mole of methane is releasing 890 kilojoules of heat. Again, mole of methane, di ba? So negative 890.3 kilojoules per mole ito. Mole of methane. Ma'am, bakit? Because ito yung binoburn nyo, guys, di ba? C, methane. Okay, not gram of methane. Therefore, A is false. Next letter B. Sabi, for every mole of methane, a half mole of water vapor is produced. Oh, guys, based on this equation alone, we know that for 1 mole of methane, okay, we produce 2 moles of water vapor. Okay? Matik, guys, tandaan, kapag magsusulat ka ng combustion reaction, dapat 1 mole ang inyong fuel. Okay? 1 mole ang inyong fuel, such as methane. Lastly, for letter C, sabi, a 445.15 kilojoules of heat is released, accompanying the consumption of 2 moles of O2. Oh, guys, hindi 445.15. Okay? So, for 2 moles of O2, guys, okay, that releases 890.3 kilojoules of heat. Gets? Okay? Bakit? Oh, for 1 mole of methane, diba? Plus 2 moles of O2, you release 890.3 kilojoules of heat. Gets? So, meaning, guys, in order for you to burn 1 mole of CH4, okay, so kailangan mo din mag-add ng 2 moles of O2 para makapag-release ka ng negative 890.3 kilojoules of heat. So, mali ang 445.15. So, the answer is letter D. All of the statements are false. Okay? Okay, next. Ayan, so done na tayo, guys, for thermodynamics 1. Now, let's proceed to thermodynamics 2. So, here you have, guys, 14 items. Ma'am, ang dami. So, guys, marami nagsasabi na maraming previous items sa boards na maraming entropy calculations. Okay? So, guys, makinig. Ayan, so for this one, number 17, which is always true about a spontaneous process. So, these are the choices, guys. Okay, so madali lang to. Kayang-kaya nito. So, for letter A, guys, it is false. Okay? Kasi syempre, yung mga spontaneous process, they can still involve work. Diba? So, matik, mali na yan si letter A. Next, letter B. Okay? So, false, guys. Bakit? Because the entropy of the system may increase or decrease, diba? During a spontaneous process. So, for example, freezing water, diba? In freezing water, guys, you are decreasing entropy, tama? And freezing water is still a spontaneous process, diba? At low temperatures, diba? At the freezing point, freezing water is spontaneous, tama? Okay. So, letter B is false. Next, guys, internal energy of the system decreases. So, that is also false because during a spontaneous process, internal energy can decrease or increase depending on the value of heat and the value of work. Oh, lastly, guys, sabi sa letter D, the total entropy of the system plus surroundings increases. Okay, so that is the definition of your second law of thermodynamics, tama ba? Okay, so sabi ng second law of thermodynamics, guys, the total entropy of the universe always increases in a spontaneous process. That's why the total entropy of the system plus surroundings increases. Oh, guys, tandaan, system plus surroundings is just equal to the universe. So the answer is letter D. Next, guys, okay, number 18. When the helium-filled balloon is immersed in liquid nitrogen, which statement actually accurately describes the changes as the balloon deflates? Okay, so you have statement 1, the nitrogen does work on the balloon. Statement 2, the entropy of the nitrogen increases. Okay, so guys, anong sagot dito? Guys, ang sagot dito ay letter C, both 1 and 2. Okay, tingnan mo natin mabuti, C statement 1, sabi, the nitrogen does work on the balloon. So imagine nyo, guys, okay, meron kang balloon, inside it you have helium. Okay, so yung system nyo, guys, is basically helium inside the balloon. Tapos, guys, yung liquid nitrogen nyo is basically outside the balloon, tama? So your liquid nitrogen, for example, this is your nitrogen. Tapos meron kang balloon dito. Ito yung balloon nyo, okay? Hindi ko, ba natin kulay, guys, sorry. So ito yung balloon nyo, yung blue. So guys, yung surroundings nyo is the liquid nitrogen. Tama? Tapos sabi dito, guys, okay, the balloon deflates. Anong meaning kapag nag-deflate yung balloon nyo? So nagdi-decrease, nagko-compress ang volume ng balloon nyo. The system is undergoing compression. Tama? Nagdi-decrease ang volume. So guys, anong nangyayari kapag nagdi-decrease ang volume or nako-compress ang system? So guys, the surroundings does work on the system, right? Okay, so assume natin, guys, yung system nyo is the helium and the balloon. Okay, so statement 1 is true, diba? The nitrogen, which is the surroundings, does work on the system, which is the helium-filled balloon. So statement 1 is correct. Okay, next, what about statement 2? The entropy of nitrogen increases. Okay, now guys, okay, the nitrogen, it is a liquid bath at constant temperature. Okay, so, ang nangyayari kasi, guys, basically is yung helium gas inside the balloon, diba? Kapag nag-deflate ang balloon nyo, syempre, saan pupunta yung helium? Syempre, i-release yan ng system nyo, tama? Kasi nga, nag-deflate ang balloon. So, the helium, as it is being released by the balloon, saan pupunta yung helium? Syempre, i-absorb yan ng inyong nitrogen, which is the surroundings, right? So, when helium is absorbed by the nitrogen, guys, okay, so, there is an absorption of heat from the helium. Gets ba? Again, si nitrogen, mag-absorb siya ng heat from the helium. Okay? So, the heat transfer of the helium, papunta kay nitrogen, increases the entropy of nitrogen. Okay, pag nag-introduce ka ng heat sa nitrogen nyo, syempre, magkakause yan ng disorder or more random motion on the molecules of your liquid nitrogen. Tama? That's why the entropy of nitrogen increases. So, the answer for number 18 is letter C. So, guys, to know how this experiment exactly works, okay, kindly watch this video.
This is a beaker full of a little bit of liquid nitrogen. I have a helium balloon here, and it's not floating because it doesn't have much helium in it, and the weight of the balloon is pulling it down. I'm also going to fill the balloon with my own breath. And then I'm going to dip the balloon in the liquid nitrogen and ask what happens to it. Shrinking. Why? Because it's cooling the air in the interior of the balloon. And in fact, kind of crackling and becoming
Ayan,
what happens to
size
helium.
pa. Ayan, helium.
With air. This is with helium. Started off a little bit bigger. We actually ran a little low on liquid nitrogen there. Basically, just to show that through the ideal gas law, PV equals nRT.
Okay guys, so ganito ha, again, yung helium gas kasi inside the balloon, di ba? At room temperature, let's say yung lalagay ng helium sa balloon, warm yan, yung helium yung at room temperature. Now, pag nilagay nyo kasi yan sa liquid nitrogen, yes, liquid nitrogen is very cold, okay? So, its temperature is around 77 Kelvin, okay? So, when you put your helium-filled balloon in nitrogen, which is very cold, the helium will lose heat, okay? To the surrounding liquid nitrogen. So, your helium, it will cool down, okay? And dahil dyan, nagko-contract, di ba? Nagko-contract ang balloon, okay? That's why the balloon shrinks, okay? Again, because of the surrounding liquid nitrogen that does work on the system. Paano ginagawa yung work on the system? So, guys, dahil gumagawa ng work ang inyong liquid nitrogen sa balloon, that's why helium cools down and therefore the balloon shrinks or nagko-compress or nagdi-decrease ang volume niya. Now, as the helium cools down, guys, helium will now release heat. Ang heat na yan ay matatransfer sa liquid nitrogen. So if nitrogen absorbs the heat, okay, its entropy will increase, okay, because of the greater kinetic energy of the nitrogen molecules, okay? Next, guys, number 19, ayan. A perpetual motion machine capable of generating increasing amounts of energy without interacting with its surroundings cannot exist. This is explained by A, first law, B, second law, C, third law, or D, Gibbs-Helmholtz equation. Okay? Guys, recall that the first law of thermodynamics states energy conservation, diba? Where energy cannot be created nor destroyed. Okay, sabi dito, perpetual motion machines, they are capable of generating increasing amounts of energy. Okay? Without any source of energy. Kaya ba? Diba? Parang nag-create ka lang ng energy from nothing. Diba? So, syempre guys, that violates the first law of thermodynamics. Okay? Tandaan guys, energy cannot be created out of nothing. Diba? Energy cannot be destroyed. It can only be transformed. Okay? Gets guys ha? Yan. Bakit mali si second law? Okay, second law relates to entropy and spontaneous processes, but it does not forbid energy creation. The third law naman is about entropy at absolute zero. So, walang connection. And lastly, guys, Gibbs-Helmholtz, walang connection, di ba? So, Gibbs-Helmholtz equation is related to free energy changes with respect to temperature, okay, and not energy conservation. Next, number 20, which of the following is an actual working perpetual motion machine. Okay, guys, kanina define na anong meaning ng perpetual motion machine. So, dapat, alam niyo na guys, na theoretic, in real life, hindi mag-exist ang ating perpetual motion machine. Di ba? In real life, guys, no machine can create energy without nothing. So, the answer is automatic, none of the above. Again, perpetual motion machines are hypothetical devices that produce work indefinitely without an energy input. Again, nagproduce ka ng work out of nothing, out of any source, okay? Which violates the first law of thermodynamics, okay? So, a coal-fired engine, we know, guys, that it is a real-life machine, di ba? Nuclear reactor, real life din. Rechargeable battery, real life din. Specifically, guys, ang coal-fired engine and nuclear reactor, they both consume fuel, di ba, guys? Kapag nagko-consume sila ng fuel, yun yung energy input. Okay? Kasi since nag-input ka ng energy, therefore they are able to produce work. Next, rechargeable battery naman, it stores energy, di ba? But it also requires input. O paano talaga input ng energy sa battery? Siyempre, charge natin, di ba? For example, yung energizer na yan, di ba? Charge natin, guys. So this is not an ad, okay? Example lang yan. Okay? Okay? So I hope guys that is clear. Again, walang actual working perpetual motion machine. You cannot generate energy, you cannot do work out of nothing. Okay? Next, number 21. Which of the following steps in the Carnot cycle absorbs heat from the reservoir? Ano kayong sagot, guys? Okay, so recall this one. Okay, again, the step 1 is isothermal expansion. Okay, guys, ang unang step sa inyong Carnot cycle is the system or the gas, they will absorb heat, right? Q in. And that occurs upon isothermal expansion. So, when your gas or your engine absorbs heat, mag-expand ang inyong gas. Tama? Mag-expand ang system. So, guys, yung expansion na yan, yung isothermal expansion na yan, is proof that work is produced. Kaya, guys, ang Carnot cycle is a good theoretical basis or concept on how Carnot engines work. Diba? Again, pag sinabi natin Carnot engines, diba? Okay, yung Carnot engine, it has to absorb heat. Tapos yung heat na yun, okay, is used in order to produce work. So, ano yung proof na work is produced? It is the expansion of your system. Okay? Yeah, so, the answer for this, guys, is letter B, reversible isothermal expansion. Q in dito. Next, number 22. The refrigerator from Todoroki Corporation TC has a COP coefficient of performance of 20, while that of the Haku Enterprise HE has 15. Which of the following is false? Okay, guys. Or recall, a Carnot refrigerator, okay, converts work in order to remove a certain amount of heat. Okay, guys, pag sinabi kasi natin na higher ang coefficient of performance, or in other words, higher ang efficiency, okay, meaning guys, more efficient ang inyong refrigerator. Okay, therefore, the refrigerator removes more heat per unit of work. Again, pag sinabi more efficient, nag-remove ang refrigerator ng more heat per unit of work. Okay? Okay, tingnan si letter A. The refrigerator from TC is more energy efficient than HE. Okay? Oh guys, this is true. Bakit? Okay, so higher ang COP ni TC compared kay HE. Diba? Higher ang COP meaning more efficient. Next, letter B. While holding other factors constant, the refrigerator from TC will consume more electricity than HE. Okay guys, ito yung false. Okay? Guys, pag sinabi natin higher yung coefficient of performance, diba? Again, mas efficient yung refrigerator nyo. So, upon the removal of heat, guys, diba? You will use less electricity kapag mas efficient yung refrigerator nyo. Kasi anong meaning pag less efficient? Okay? So, in order to remove heat, kailangan nyo mag-use up ng more electricity. O recall guys, sa Carnot refrigerator concept, diba? You have to input work in order to remove heat from the cold reservoir. Tama? So, yun yung concept ng refrigerator, guys. So, bago ka mag-remove ng heat, okay, again, you have to consume electricity. Yun yung work input nyo, yung kinonsume na electricity. Okay, so kung less efficient yan, edi kailangan mo mag-consume ng more electricity in order for you to remove heat. Okay, so bakit B is false? Sabi dito guys, yung refrigerator from TC will consume more electricity than HE. Guys, the refrigerator from TC has a higher COP. So we would expect that it will consume less electricity than HE. Gets? Again, kasi mas efficient siya. Okay? Or letter C, while holding other factors constant, the refrigerator from HE will remove less heat from the refrigerated space. Okay, so guys, this is true. Okay, kasi pag sinabi natin lower ang coefficient of performance or efficiency, lower efficiency, less heat is removed, diba? Less heat is removed kapag lower ang COP per unit of work. Okay? Lastly, D is wrong. So the answer is letter B. Again, ang false lang dito is letter B. Dapat TC will consume less electricity because it is more efficient. And in real life, guys, tama naman, di ba? Pag more efficient, kaya nga, di ba, ang guys, yung mga mamahalin na refrigerator na binibili, di ba? Yun yung binibili yung mga mas mahal. Bakit? Kasi mas efficient daw. O, anong yun mas efficient? Siyempre, guys, binibili natin yung refrigerator na nag-use up ng less electricity. Di ba? Siyempre, guys, di ba? Gusto natin na less electricity yung gamitin para mas onti yung bayad sa Meralco. Di ba, guys? Gets ba? Okay. Ayan, next number 23. The quantity T times delta S may be expressed in units of. O, guys, paano kayo ito sinagutan? Okay, so T delta S, guys, ang technique dito, tingnan niyo lang yung units of T and delta S, tapos multiply nyo sila with each other. So the SI units of temperature is Kelvin, right? Well, the SI units of delta S is J over Kelvin. So K times J over Kelvin, cancel K, that is equal to joules. So anong sagot? Siyempre si letter A. Okay? Next, number 24. A reaction has both positive delta S not positive standard enthalpy change and positive standard enthalpy change values. Which of the following is correct? Okay, so these are the choices, guys. Okay, ano kayang sagot nyo? Okay, so guys, answer here is letter D. The temperature of the reaction mixture will decrease if done in an insulated container. So tingnan natin isa-isa, guys. Okay? First, for letter A, di ba, ang statement dito sabi, it will occur spontaneously at 298 Kelvin and 1 atmosphere. So guys, bakit mali si letter A? So kasi hindi tayo pwede mag-conclude. Di ba? Wala naman tayong given na actual values ni standard enthalpy delta S and delta H naught in order to determine the spontaneity at 298 Kelvin. Therefore, A is false. Next, letter B sabi, as the temperature is increased, the equilibrium constant decreases. Oh guys, okay, in an endothermic reaction, okay, we call that increasing the temperature, shifts the equilibrium to products. Di ba? Again, just recall Le Chatelier's principle, di ba? If for an endothermic reaction, okay, if you raise the temperature, if you increase the temperature, it will shift the equilibrium to products. Okay? Okay. That's why what will happen to KEQ if papunta tayo sa product formation, if yung equilibrium papunta sa product. So syempre guys, KEQ must increase, not decrease. Again guys, kailangan mo ng high KEQ in order for product formation to be favored. Okay? Then guys, you call Le Chatelier's principle. Next, letter C. Okay, the reaction has more moles of products than the reactants. Okay? So guys, yung positive, the delta S naught, okay, it may suggest that there are more moles in the products, especially for gases. Pero guys, hindi ito guaranteed kasi wala naman tayong given na balance equation. Lastly, for letter D, this is the correct answer. Okay? So sabi sa letter D, the temperature of the reaction mixture will decrease if done in an insulated container. Oh guys, pag positive ang delta H naught, meaning endothermic ang reaction, diba? So here you will absorb heat, the system will absorb heat. So in an insulated system, guys, okay? Tandaan, pag insulated yung system, di ba? Bawal pumasok yung heat from the surroundings, right? Bawal pumasok sa system yung heat from the surroundings. So in an insulated system, okay, ano kayang mangyayari? Okay? This will only lower the mixture's temperature. Klaro? Klaro ba? Ma'am, bakit? Again, if for example, nag-increase yung entropy inside the system, okay? So what happens is that yung temperature ng inyong system will only decrease. Okay? In this case, guys, nag-increase ang entropy pero hindi naman siya nag-absorb ng heat kasi again, you have an insulated container. Okay? Ayan. I hope it's clear, guys. Ayan. Number 25. Which of the following are true? Okay. 1. Equilibrium is reached if delta G is equal to 0. 2. Delta G naught is equal to negative RT, L, and KQ. 3. The standard delta G is independent of pressure. Oops. Ano kaya yan? Okay, guys. Tingnan mabuti. Okay. Ayan. So, lahat sila true, guys. Okay, ayan. Makinig. For statement 1, is this true? Bakit? Okay, we know, guys, that at delta G is equal to 0, we have equilibrium. Statement 2 is also correct. This is your equation that links the standard gives free energy and equilibrium constant, right? Oh, yan. Si statement 3 yung mahirap dyan. This is the standard gives free energy change. Okay? So, the delta G naught is defined at standard pressure. Recall, guys, pag meron tayong naught, again, this is the delta G in standard conditions. Okay? So it is a constant reference value. Okay, so for standard conditions, guys, okay, syempre constant ang pressure, diba? The pressure is equal to 1 bar for standard conditions. So basically, guys, yung gives free energy na yan, measure in standard conditions. Okay? Where the pressure is equal to 1 bar. Okay? That's why the answer is letter B. Okay? Oh, ma'am, kailan magiging mali C3? Syempre, guys, kapag delta G yan, pag walang not. Kung delta G lang yan, guys, pag walang not, statement 3 is false. Okay? Because, again, bakit delta G is dependent of pressure? Recall, guys, the fundamental equation for G, Tg, is equal to negative SdT plus VdP, remember? Let's recall that again. Negative SdT plus VdP ang ating fundamental equation for Tg. So what does this mean? Your Gibbs free energy, the thermodynamic potential, okay, is dependent on temperature and pressure. Gibbs free energy is a function of temperature and pressure. So kung walang not yan, syempre 3 is false, okay? Dahil delta G is dependent on pressure, okay? Ayan. Again, ang correct answer for number 25 is letter D. Next, number 26, equilibrium constant of an exothermic reaction blank when the temperature increases. Okay, so we are given here these choices: increases, decreases, does not change, decreases first, then increases. Okay, guys, for an exothermic reaction, okay, so there are 2 ways in answering this question. So una, I using the Van Hoff equation here. L and K is equal to negative delta H over R times 1 over T plus delta S over R. Okay, so we know, guys, that for an exothermic reaction, delta H is less than 0. So the slope, which is negative delta H over R, this whole expression here is positive. Now, guys, base problem, T increases. So what can we say about 1 over T? 1 over T decreases. Okay, since this slope here is positive, okay, decreasing 1 over T causes L and K to decrease. Again, since 1 over T is decreasing, tapos delta H over R is positive, okay, meaning if that 1 over T is decreasing, L and K is also decreasing. Thus, as T increases, guys, K decreases. Okay, so the answer is letter B. Now, guys, we can also use the Le Chatelier's principle in explaining this question. Okay, so guys, you know that if you increase the temperature, di ba, ano nangyayari? Nag-add ka ng heat sa inyong product side, di ba? Or recall, guys, kapag nag-release yung heat sa product side, right? So if you are adding more product, which is the heat in the product side, okay, the equilibrium shifts to the left towards reactant formation to counteract the change, di ba? That's why in that case, if the equilibrium shifted to the left, fewer products are formed, and that results in the decrease in the equilibrium constant. Okay, and so there are 2 ways again to answer this one. First, using the Van Hoff equation. Second, using the Le Chatelier's principle. Next, again, this is the trend, guys. If exothermic delta H is less than 0, shifts toward reactants ang ating effect based on the Le Chatelier principle. And that results in the decrease in the KQ. Whereas guys, pag endothermic, okay, kunwari nag-add ka ng heat in your reactants, which is correct, diba? Because your reactants will absorb the heat, right, in endothermic reactions. So if you have more heat in the reactant side, therefore the equilibrium will shift towards product formation, diba? So right, so forward shift. And that results in an increase in KQ, okay? Next guys, number 27, okay? What is the standard delta G of the formation of NO gas if its standard enthalpy of formation is 90.3 kilojoules per mole? The standard absolute entropies, J over mole, K, for gaseous nitrogen, oxygen, and NO are 191.6, 205.2, and 210.8. Okay? So guys, we need to solve here, okay, delta G of formation, okay? So guys, to solve the delta G of formation, we have to determine the standard entropy change first, okay? The standard entropy change first, okay? Bago natin ma-solve si delta G of the formation of NO. So to get the standard entropy change, that is equal to the standard entropies of your products minus the standard entropies of your reactants. Now guys, anong equation na gagamitin? Wala tayong given equation, tama? So we have to make the equation on our own. We have here formation of NO, tapos ang clue nyo guys, yung reactants nyo is nitrogen N2 and oxygen O2. Now guys, tandaan, pag gagawa kayo ng formation reaction, dapat assume that you will form 1 mole of your product. 1 product, okay? Hindi 2. Claro guys? That's why the correct formation reaction is 1 half N2 plus 1 half O2 forms 1 NO. Now we can solve for the standard entropy change. Okay, so the standard entropy of your product NO is 210.8 times 1 minus standard entropies of your reactant, so quantity of 1 half times 191.6, so this is standard entropy of N2 plus 1 half times the standard entropy of O2, 205.2. So solving guys, you will get that the standard entropy is equal to 12, standard molar entropy, okay, is equal to 12.4 J over mole. Okay, ma'am, bakit molar entropy? Kasi per mole siya, okay? Now guys, we can now determine the delta G of formation, okay? Okay, take note guys, delta S naught, okay, convert lang natin siya to kilojoules, okay? Where delta S naught is now equal to 0.0124 kilojoules, okay? Anong gagawin equation? Syempre ito guys, di ba? Ma'am, bakit? Kasi given na tayo ng enthalpy of formation, which is 90.3 kilojoules per mole. So, dire-diretso na ang pagsabot nito. Tapos, given din tayo guys ng temperature. O guys, ano kaya ang temperature? Any guess? O sabi dito, standard delta G of the formation. So, your temperature guys is in standard conditions. Again, the temperature in standard conditions is 298 Kelvin, okay? So, delta G naught is equal to 90.3 kilojoules per mole, the standard enthalpy change, minus 29. Again, this is the temperature in standard conditions. Hindi STP ha. Again, in standard conditions, times delta S naught, 0.0124 kilojoules per mole. Okay, so cancel Kelvin. And you will get delta G naught is equal to 86.6 kilojoules per mole, letter B. Okay? Ganyan na. I hope that's clear, guys. Next, ayan, we have here a previous board exam question. Predict the signs of delta H naught, standard enthalpy change, and standard entropy change for this reaction. So we have here H2 hydrogen gas plus O2 gas, which forms water vapor gas. Okay? Guys, these are the choices. And ito ang reaction mo. 2H2 plus O2 forms H2O gas. Oh guys, when hydrogen and oxygen atoms combine to form water molecules, syempre guys, meron kang formation of new chemical bonds, diba? Between O and H. Okay? So guys, when you form new bonds to make a new compound such as water, okay, formation of bonds releases energy. Or recall guys, pag bond formation, diba, bond forming, release energy. Bond breaking, absorbing energy. That's why the overall process in this case is exothermic. So we have a negative delta H naught. Next, what about delta S naught? Oh guys, tingnan sa reactant side, you have 2 moles of gas, H2, plus 1 moles of O2. So meron kang 3 total sa reactant side. Pero sa product side, you only have 1 mole of gas. Tapos both yan gaseous state, diba? So guys, both sila gaseous state. So i-compare na natin yung number of moles nila. Okay? So reactants have 3 moles of gas, while products have only 2 moles of gas. That's why delta S naught is negative. Because in your product side, you now have fewer number of moles of gas. Okay? So the answer for number 28 is letter A. Okay? Again guys, kapag titingin kayo ng delta S naught, tingnan nyo muna yung state ng inyong reactants and products, diba? So for example, liquid to gas. Okay? So that results in an increase in entropy in general. Kailan kayo guys titingin sa number of moles in the reactants and products? Titingin na kayo sa number of moles sa inyong reactants and products kapag same ang state sa reactants and products. In this case, guys, same, diba? Nag-gaseous state ang reactants and products. Okay? Next guys, number 29. Ayan. What is the delta S of the process when 10 kilograms of water at 10 degrees Celsius is mixed with 2 kilograms of water at 100 degrees Celsius? Assume that the container is isolated from the surroundings. Ayan, so meron tayong isolated system. Okay? So anong meaning yan? Pag minix mo yung cold water, okay, which has a temperature of 10 degrees Celsius with the hot water 100 degrees Celsius, guys. Okay? Okay? Basically, okay, yung hot water, mag-lose siya ng heat. Bakit? Kasi yung heat na yan pupunta sa cold water. Again guys, imagine mixing 2 waters with different temperatures. So guys, these are the choices. And again, we have here cold water with a mass of 10 kilograms, initial temperature of 283 Kelvin. Okay, so 10 degrees Celsius converted to Kelvin. Okay, ma'am, bakit convert to Kelvin? Again, we have to get delta S. Again, your delta S, guys, is in terms of J over Kelvin, tama? So we have to convert to Kelvin first. Next, hot water naman, mass is equal to 2 kilograms, temperature is equal to 373. Again, guys, okay, bakit adiabatic and isolated ang system? I-assume natin yan because, again, sabi dito, the container is isolated from the surroundings. Meaning, guys, the heat loss by your hot water is equal to the heat gain by your cold water. So, equate natin, Q cold is equal to Q hot water. Okay, again, guys, si cold water nag-gain ng heat, si hot water nag-lose ng heat. Okay, so this is the equation, guys. For cold water, Q of cold water, heat gained by cold water is mass 1 times the specific heat capacity of the liquid water times TF final temperature after mixing minus T1. Recall, guys, we assume ideal mixing in this case kasi again, walang heat na lumabas sa container kasi nga isolated ang container from the surroundings. And then let's get Q hot water. This is the heat lost by your hot water. M2 times specific heat capacity of liquid water times T2. Okay, again, guys, yung hot water, yung temperature niya is higher than the final temperature because again, nag-lose ng heat sa hot water. So T2 minus TF. Okay, so substitute lang guys and you will get this expression here. So convert kilograms to grams. Okay, bakit? Okay, guys, recall, ang ating specific heat capacity ay in terms of 4.18 joules over grams times temperature. Okay? So convert to grams. So solving guys, you will get this one. Ayan. The final temperature is equal to 298 Kelvin. Okay? So guys, hindi tatapos dyan. Okay? Hindi tatapos dyan, ha? Okay. So to get the entropy of the process, we just have to add them all up. So add the delta S cold to the delta S hot. Okay? Additive lang silang dalawa. So how do we get the delta S? The delta S is due to the temperature change. Okay? Again, delta S is due to the temperature change. Ma'am, question. Napansin ko lang yung hot water nasa boiling point na hindi ba dapat magbo-boiling water? Guys, hindi. Bakit? Kasi minix mo siya with cold water. So guys, ano mangyayari pag minix mo with cold water kahit sa boiling point? Syempre lalamig yan. Klaro guys? So that's why hindi magbo-boil si hot water kasi minix mo na siya with cold water. Okay? Okay, so now let's determine delta S code. Delta S code is equal to MCP ln T2 over T1. Again, delta S due to temperature change kasi wala kang phase change. Okay? So M, the mass of your cold water, 10 times 10 to the power of 3 grams, times CP in terms of J over grams times Kelvin. Again, bakit? Kasi kailangan yung sagot natin in terms of J over Kelvin. Times Ln, T2 over T1, 298 divided by 283. Again, T2 here, 298 is the final temperature, sinolve natin kanina. Plus delta S hot, so that is 2 times 10 to the power of 3 grams of your hot water, times CP of liquid water, times Ln, 298, the final temperature, divided by 373 Kelvin. Okay, that's the initial temperature of your hot water. So solving, guys, you will get delta S total is equal to 282 J over Kelvin. Letter T. Kayang-kaya, guys, diba? Kailangan lang ng maraming practice. On next, number 30. What is the absolute entropy of a system that has 45 microstates? Guys, to solve this problem, guys, you just use the Boltzmann entropy formula. The absolute entropy S is equal to the Boltzmann constant times Ln microstate. Okay, again, this omega here is the number of microstates. So here you are given 45 microstates. So substitute lang, guys. S is equal to KB Ln 45. Or recall, guys, ano nga bang constant sa calculator ang KB? KB, guys. KB is constant. Yeah, double check lang, guys. Wait lang. KB is shift, convert, 25. Again, to get KB on the calculator, Boltzmann constant, this is just shift, conv, or cons 25. Okay? KB is just equal to K there. Okay? So the answer is letter A. 5.26 times 10 to the power of negative 3 J over Kelvin. Ayan. So now we are done with thermodynamics 2, guys. Okay? Medyo mahaba yun. So now let's move on to the gaseous state. Okay? So for the gaseous state, guys, you also have many items. You have here 11 items for the gaseous state. So makinig. Again, guys, lumalabas sa board exam ang conceptual and solving questions on ideal gases and real gases. So dapat pay attention to the gaseous state. Okay? Okay, guys? Number 31. Gas pressure is caused by, so this is a previous board exam question. A. Increasing volume. B. Heating of the gas. C. Gas molecules hitting the wall of the container. Or D. Gas molecules hitting other gas molecules. Kasi nga natin isa-isang sagot. For letter A, guys, that is false because we know that increasing volume will decrease the pressure. Diba? Gets ba? So, you have decreasing pressure. Next, pag nag-decrease ang pressure, guys, okay, hindi ibig sabihin yan. So, hindi yan yung definition ng gas pressure. Okay, next for letter B, also false. So, heating of the gas increases the kinetic energy. When you have a greater kinetic energy for your gaseous molecules, okay, you have more collisions, okay, between the molecules, okay? Pero guys, tama naman, diba? Pag, for example, greater kinetic energy, syempre, yung molecules nyo, more collisions with the container. However, guys, yung heating itself, which is the point of letter B, the heating itself is not the direct cause of pressure. Next, letter C. Okay, mamaya sa letter C, letter D muna. For letter D, guys, gas molecules hitting other gas molecules. So, guys, yung collisions na yan will help distribute the energy, but it does not directly cause the pressure on the container walls, okay? So, guys, gas pressure is mainly caused by the gas molecules colliding with the wall of the container. So each collision, guys, for example, sa figure na yan, each collision transfers momentum to the wall. O recall nyo ba? Nalala pa ba yung video natin on the deriving of the ideal gas law? O guys, yun yung basis noon, di ba? Kasi each collision has transferred momentum to the wall. Okay? So yung effect niyan, okay? So yung effect ng maraming gaseous molecules mag-collide with the container to create momentum creates gas pressure. So the answer is letter C. Okay? Again, answer is letter C. This is the previous board exam question. Okay? Next, number 32. Which of the following is true about an ideal gas? Okay, so nasagot, guys. Okay, so tingnan natin isa, guys. For letter A, it is true. We know, guys, that the ideal gas law is PV is equal to nRT. Right? And here you don't have the A and B empirical constants, which we see in your modified equations of state for real gases. Okay, so therefore A is true. Next, B is also true. Sabi dito, the interaction between particles is negligible. Tama, guys, diba? In the ideal gas model, the particles do not attract or repel each other. Meron ka lang elastic collisions. So B is true. Lastly, for letter C, there is no temperature change upon expansion, guys. Also true. Okay, guys, we know that upon expansion of the ideal gas, hindi yan mag-cool or warm, diba? Kung saan lang ito nag-apply? Again, for real gases, right? For example, real gas, pag nilagay mo sa Joule-Thomson apparatus, diba? It will either cool or expand upon expansion. Or cool or warm upon expansion. Pero guys, in the case of your ideal gas, it will neither cool nor warm upon expansion in the Joule-Thomson apparatus. That's why the answer for number 32 is letter D. All of the above. Okay? Next, guys, number 33, previous board exam question then, which the following pairs is directly proportional for an ideal gas. Okay, so guys, in this question here, just look at the formulas for the molecular velocity. Guys, dapat by now memorize na to. Okay, guys, dapat ang tip ko sa inyo, ngayon pa lang, dapat memorize nyo na yung mga equations sa FICAM. Bakit? Para later on, guys, hindi nyo naisipin. Guys, 2 months na lang, diba? Board exam na. No pressure. Pero guys, dapat may onting na, diba? Guys, dapat, ngayon pa lang, as early as memorize nyo ng formulas. Para later on, ang iisipin nyo na lang is how to master answering FICAM type of questions. Klaro ba? Again, dapat memorize na ang equations. So guys, look at the root mean square, average, and most probable velocity equations. Diba? Your V, which is the velocity, is directly proportional to the square root of T. So therefore, the answer is letter C. Ma'am, what about V and the square root of the molar mass? So guys, V and the square root of the molar mass are inversely proportional. That's why guys, yung mga mabibigat na gases, they move slower. They have lower velocities. Okay? Next guys, number 34. Ayan, paano nyo kaya sinagutan to? Okay, number 34. What is the root mean square velocity of bromine gas? Pag sinabing bromine, PR2. Klaro? Again, PR2 gas at 105 degrees Celsius. So guys, to get the root mean square velocity, use this equation. Ayan. Mu, root mean square velocity is equal to square root of 3RT over M. To solve guys, ayan. Okay? Excuse me. Square root of 3 times R, 8.314, times 378 Kelvin. This is 105 degrees Celsius. Tandaan guys, convert lagi degrees Celsius to Kelvin. Okay? Divided by, ayan. The molar mass. Oh guys, the molar mass of BR2 is 159.8 grams per mole. Now guys, gawin natin SI units ng grams. Convert grams to kilograms. Ma'am, bakit? Kasi dapat makuha yung velocity I in terms of SI units. O anong SI units ng velocity? Guys, it is meter per second. Okay, so again, you have to convert the molar mass to kilograms. 159.8 grams, convert kilograms. Okay, so 1 kilogram is equal to 1,000 grams. Solving guys, you get 240 M over S. I hope that's clear guys. Next, number 35. A gas is allowed to expand until its volume is twice its original volume. Which of the following statements is true? So these are the choices guys. Medyo tricky to guys, makinig. Okay. Sabi, a gas is allowed to expand until its volume is twice its original volume, which is following is true. So guys, letter A, whoops. Sabi dito, the pressure increases 2 times. Oh guys, tandaan, if the gas expands, pressure should decrease. So mali si A. Next, letter B, sabi dito, the pressure decreases by half. Oh guys, true lang ito if temperature is constant. Oh guys, sa problem ba sinabi ba na temperature is constant? So guys, syempre, letter B is false. Kasi hindi naman sinabi guys na constant temperature yung process na ito. Guys, kung constant ang temperature, then we can use the Boyle's law to relate pressure and volume with one another. Tama? Again, this is only applicable for constant temperature. Again, B is false. Next guys, letter C. The temperature increases 2 times. Okay? So guys, paano nga ano bang gas ito nag-relate ng volume and temperature? It is Charles' law, diba? V1 over T1 is equal to V2 over T2. Take note guys, magagamit nyo lang to if you have a constant pressure process. Okay? Wala namang sinabi dito guys that the pressure is constant. So we cannot use the Charles' law in this case. Okay? Wala tayong enough information to say so. Therefore, C is false. Therefore, the correct answer guys is letter D. Okay? Bakit? Wala tayong enough information. Bakit kasi hindi sinabi kung constant temperature or constant pressure ang process? Okay? So guys, kailangan natin yun in order for us to conclude kung gagamit tayo ng Boyle's law or Charles' law. So the answer guys is letter D. Not enough information. Okay? I hope that's clear guys. Next. Number 36. Ayan. Which of the following statements are true about ideal gases? Okay. So sabi dito sa first statement, pressure exerted by each gas in a gas mixture is independent of the pressure exerted by all other gases. 2. The total pressure exerted by a mixture of gases is the sum of the partial pressures of the component gases. 3. The amount of gas present in a mixture may be described by its partial pressure or its mole fraction. Guys, lahat ng mga concepts na to are described by the Dalton's law of partial pressures. Tama? Diba guys? Tama lahat. Pressure exerted by each gas in a gas mixture is independent of the pressure exerted by all other gases. Kaya nga guys, na-add natin lahat ng partial pressures ng components ng gas nyo. Tama? Statement 2 is also correct. Bakit? This is just basically the Dalton's law. PT is equal to the sum of the partial pressures of your components of gas. Lastly, that statement 3 is also correct. Okay, so the amount of gas present in a mixture may be described its partial pressure or its mole fraction, where Yi is the mole fraction of the component I in the gas mixture. So guys, the answer is letter C. 1, 2, and 3. Okay, again guys, the Dalton's law is applicable for ideal gases, diba? Next, number 37. Okay, so similar board exam question guys. Again, lumabas na to for the past 2 years. Okay, again guys, saan nagkakamali lagi? Again, in terms of the degrees Celsius conversion. Okay, so number 37, a gas at 25 degrees Celsius, 1 atmosphere and 2.5 liters expands to 0.85 atmosphere and 15 degrees Celsius. What is its final volume? So guys, in this case, gagamitin natin ang combined gas law. Ma'am, bakit? Okay, wala namang ibang equation, diba, na magre-relate sa mga variables na to. Okay, tapos kailangan pa hanapin yung volume. So syempre guys, assume ideal gas behavior in this case. Okay, so we have here again combined gas law. So substitute lang guys. Okay, again, convert temperature to Kelvin. So 25 going to 98, C15 going to 88. So for P1, that is 1 atmosphere times 2.5. Okay, for P2, 0.85 atmosphere times V2. So V2 guys ang hinahanap natin. So shift solve lang. And you will get V2 is equal to 2.L. So the final volume is, letter C, 2.8 liters. Okay? Number 38 guys. Ayan. Okay, so this is a previous board exam question. Which of the following are true about the van der Waals equation of state? 1. The volume correction is denoted as P. 2. The pressure correction is the term with A. 3. The term B is 4 times the volume of particle. Okay, so guys, ang correct answer dito ay letter D, 1, 2, 3. So let's examine all choices guys. Okay, makinig. Okay, makinig kasi itong part na to, syempre hindi ko na pala discuss, diba? Lalo statement 3. Oh guys, expect na hindi lahat ng, syempre guys, sa board exam, diba? Merong minsan surprise questions. Okay? Okay, so paano natin masasagutan yung mga surprise questions? So guys, more reading lang yan, okay? Again, okay guys, unahin natin statement 1. Okay, so the statement 1 is true. You know guys that the term B corrects the volume. Bakit? It accounts the individual volume or the finite size of your gas molecules. Again guys, based on the real gases guys, pag real gases, again, significant na ang individual volumes or finite sizes ng gas molecules nyo. So kaya nga guys, diba, for example, in the van der Waals equation of state, or recall the van der Waals equation of state is nRT over V minus NB minus N squared A over V squared. Tama? O meron kang V minus NB dito, so your B here will correct the volume. The volume here, V, is the volume of your gas, diba? In general, the total volume of the gas in a container, right? So B again accounts for the individual volumes or the finite sizes of your gas molecules kasi significant na sila for real gases. Next statement 2 is also true. So here guys, you have here N squared A over V squared term, right? So this term here contributes to pressure, tama? So for example, high CA guys, okay, again, high CA, okay, that results in a pressure decrease, okay? And that's why A, okay, refers to the pressure correction, okay? Again, A here, the A accounts for the attractive forces between the real gas molecules. Siya yung constant na nagtitake ito account sa interactions between the real gas molecules. Kasi guys, for statement 3, dito makinig, okay? Guys, in the van der Waals equation, okay, the correction term B is not just the volume of a single particle or molecule. So guys, often guys, B is approximated as 4 times the individual volume of the particle times the Avogadro's number. Yes, therefore the answer is statement 1, 2, and 3. Again guys, B is equal to 4 times the individual volume of the particle times the Avogadro's number. Okay, I'll take note of that. Diba? Bagong info yan. Okay. Okay guys, so how about for number 39? What is the temperature of a mole of van der Waals gas if its volume is 10 liters and pressure is 300 kilopascal? So we are given here A, which is equal to 0.137, and B, which is equal to 38.7 times 10 to the negative 6. Okay, so guys, notice na yung units ng A and B nyo, okay, are in terms of SI units. So make sure guys, when answering this question in terms of SI units, okay? So let's solve guys. So these are the given, okay? And then we have to solve again for the temperature. Okay, so given naman lahat guys, pero convert lang natin si pressure in terms of 300 kilopascal. Gawin natin pascal, okay? Where 1 kilopascal is equal to 1000 pascal. Okay guys, so recall ha, ito ang correct equation natin for the van der Waals equation, walang bar, okay? So guys, again, walang bar. P is equal to nRT over V minus NB minus N squared A over V squared. Again guys, walang bar yan. Okay. So substitute lang sa ating equation dito. So pressure is equal to 300,000 pascal, okay? Which is equal to nRT. What is the N? We are given here 1 mole of van der Waals gas, 1 times R times T. T again ang hinihingi sa problem. Divided by V, which is given, that is the 10 liters. Convert liters to cubic meters, which is the SI units for volume, where 1 cubic meter is equal to 1,000 liters. Guys, important na memorize nyo ito ha. 1 cubic meter is equal to 1,000 liters. Minus NB, again, your moles is 1 mole, times B, which is given, 38.7 times 10 to the negative 6. Next guys, minus N squared A. So N here, N squared is just 1 squared, times 0.137. This is a given constant A. Divided by V squared, so 10 liters convert to cubic meters squared. Again, 1 cubic meter is equal to 1,000 liters. So solving guys, all you have to do is shift solve and you will get temperature is equal to 359 Kelvin. Ang nearest dyan guys is si letter A. Ma'am, confused ako, bakit hindi siya V-bar? Bakit hindi molar volume? Okay guys, so dito kayo makinig, okay? So again, sorry for the confusion guys, okay? Tandaan, V bar again is equal to V over N, tama? So if for example, molar volume ang binigay sa inyo, V bar ang meaning yan, okay? So the equation will now become P is equal to RT over V minus P, V bar. minus A over V bar squared. Gets? O sige, prove natin guys that this equation here is just equal to this one. Okay? So ang gagawin ko is to V bar, make V bar equal to V over N. Again, V bar is equal to V over N. So gagawin natin V over N yan. So ang equation dito guys sa taas will become V over N minus B. Okay, tapos ito naman magiging okay, V squared over N squared. Okay? Because again, V bar is equal to V over N. Okay? Ganyan yan. I hope that's it, guys. Ayan. So guys, gusto natin syempre yung N na sa numerator, tama? So ang gagawin natin sa denominator dito sa left expression natin is to multiply B by N. Bakit? Para ma-divide natin both V and B by N. Klaro guys? Again, ma-divide natin ang dalawang ito by N. O N over N is just equal to 1. Kaya pwede natin gawin yan kay B. So guys, N here is at the denominator. So flip lang natin. Malalagay na siya sa denominator. Gets ba guys? So this will become NRT over V minus NB. Next guys, N squared and sa denominator, flip lang natin. Mapupunta yan sa numerator. Okay? So this will become N squared A over V squared. Gets guys? Okay? I hope that's clear. Okay? Yeah. So again, ang nearest answer ay letter A. Next, number 40. Which of the following is true for our real gas? Ano ba sasabihin nyo? Tama? So bilisan natin yung pagsagot ito. Okay? So guys, the answer obviously is letter B. Diba? Ang proof niyan ay ang Joule-Thomson experiment, right? Where the real gas can cool or heat when expanding in the Joule-Thomson apparatus. The items A and C, guys, describes ideal gases, okay? Not real gases, okay? Okay. Again, that is letter B for number 40. Lastly, guys, number 41. Which condition does not indicate a predominance of repulsive forces? So we are given here. A, the value of Z is 1.0053. B, the value of the fugacity coefficient is 1.0075. C, the value of the Joule-Thomson coefficient is 0.24 Kelvin over atmosphere. D, none of the above. So guys, again, for repulsive forces, tandaan, Z is greater than 1. Fugacity coefficient is greater than 1. Therefore, the mu JT, okay, for repulsive forces is less than 0. Tandaan nyo lang guys, diba? Pag repulsive forces, C is greater than 1, fugacity coefficient is greater than 1. So what if guys, meron tayong repulsive forces, okay? Upon expansion of your gas, diba? The gas will warm upon expansion, diba? Okay, so ito yung condition. Now, sabi dito C is equal to, the mu JT is equal to 0.24. So your mu JT here is greater than 0. Okay, so in this case guys, okay, meron tayong expansion, diba, of the gas. Tapos yung gas yung mag-cool, cooling upon expansion. Okay? So guys, saan yung related, diba? If Z is less than 1, fugacity coefficient is less than 1, diba? You have attractive dominating forces. And this two conditions here corresponds to mu JT greater than 0. That's why the answer for number 41 is letter C, because it refers to attractive dominating forces. Okay? So guys, when attractive forces dominate, diba yung molecules nagpo-pull on each other. Okay? So yung expansion, okay, pag pilitan siyang mag-expand, imagine nyo, gusto niya nga mag-compress, diba? Kasi molecules pull on each other. So imagine guys, pipilitin natin sila mag-expand on the Joule-Thomson apparatus. Okay? So if you want to force them to expand, okay, you have to use up energy, you have to use up heat inside the system of your gas in order to separate the molecules or break apart the IMFAs between the molecules. And that causes cooling. Basically guys, okay, yung attractive dominating forces, pag pinipilit silang mag-expand, nasasad sila. Kaya nag-cool sila upon expansion. Okay? That's why for attractive forces, mu JT is greater than 0. Okay? Yan, so tapos na tayo sa ating gaseous state. Now, let's proceed to the questions on the liquid state. So we have 4 questions. So for number 42, which of the following is not a unit of viscosity? So these are the choices, guys. Okay, so like kung memorize nyo yung units of viscosity na discuss natin, pati yung units of surface tension and so on and so forth, you would know that the correct answer is, of course, letter A. Because J over M squared is the SI unit for surface tension. It is also equivalent to N over M, diba? Okay, so look at the other choices, guys. B, centipoise, this is your CP, tama? Again, this is your CP, and you know that it is the unit of viscosity, where the 1 Pascal times second is equal to 10 poise. Tapos from the poise, guys, pwede nyo makuha si centipoise, diba? Next, guys, G over centimeters per second is the CGS unit for viscosity. Lastly, Pascal times second is the SI unit for viscosity. Okay? Very easy, guys, right? Next, number 43. All of the following properties of liquids increase with increasing strengths of intermolecular forces except A, boiling point, B, enthalpy of vaporization, C, vapor pressure, or D, viscosity. So guys, let's look at the choices. Okay, for letter A, we know that if we increase IMFAs, that results in an increase in the boiling point, diba? Alam niyo na yan, guys, from in org pa lang, diba? So, stronger intermolecular forces require more energy or more heat in order to separate the molecules into vapor. Okay, so the boiling point, or the boiling point required to vaporize or boil your liquid to turn it to vapor phase, okay, is increasing. Next, for letter B, okay, so recall that the enthalpy of vaporization is the amount of energy you need in order to vaporize a mole of liquid. Okay, so if you have stronger IMFAs, guys, then your liquid should absorb a larger amount of enthalpy of vaporization. It needs a higher enthalpy of vaporization. Therefore, B is increased. Next, letter D naman muna. Okay, so guys, if you have stronger IMFAs, then the molecules will quote-unquote stick together. Okay, and that makes the liquid flow less easily. Therefore, it has a higher viscosity. Okay, so for letter C, okay, tandaan guys, if you have stronger IMFAs in your liquids, it will be harder for your liquid molecules to break its IMFAs and then escape into the vapor phase. So guys, if you have fewer molecules that escapes into the vapor phase, guys, you have a lower vapor pressure. Okay, that's why the answer for number 43 is letter C. Next, number 44. Okay, so what is the ratio of the differential pressure of a 1 centimeter radius water bubble? Guys, nagtataka ko lang nagtanong sa akin kung ano yung surface tension value. Okay, so sinerch niyo ba? Okay guys, so polish hindi ko na send sa inyo yung surface tension ng water. So guys, in order to solve this problem, you have to know the surface tension of water. So guys, ang gagamitin natin in determining the surface tension is the bubble method, where surface tension is equal to delta P, the differential pressure times R over 2. So we are given here, guys, the 1 centimeter radius just converted to meters. And then guys, okay, take note, the surface tension of water is 0.075 N over M. So shift solve lang guys, let's get the ratio of the differential pressure, that is just delta P. So 0.075 is equal to delta P times 1 times 10 to the power negative 2 meters, that is the radius divided by 2. Solving, we get delta P is equal to 14.5 Pascal. So the answer is letter B. Okay. Next, guys, number 45. The surface tension of toluene at 20 degrees Celsius is 0.0284 N over M, and its density at this temperature is 0.866 grams per cubic centimeters. What is the radius of the largest capillary that will permit the liquid to rise to 2 centimeters? So, guys, ang keyword natin dito ay capillary, tapos nag-rise ang liquid to 2 centimeters. So, in order to calculate for the surface tension, let's use the capillary rise method, where gamma, your surface tension, is equal to EGHR over 2 cos theta. So, guys, we are given here the surface tension of your toluene, okay, that is 0.0284. We are also given here the density, 0.866 grams over cubic centimeters. Take note, guys, that dapat i-convert natin ito in terms of SI units, okay? So ang hinahanap natin dito guys is the radius r. We are also given here the height, diba? Which is 2 centimeters. Again, you convert that to 2 meters. 2 times 10 to the power of negative 2 meters. Then guys, yung cos theta natin is just equal to 1. Bakit? Because we're not given a contact angle here. So let's assume that cos theta is just equal to 1. So let's simplify your equation to gamma is equal to PGHR over 2. So shift solve lang ulit guys. Okay? So your gamma surface tension is 0.0284 is equal to density 0.866 grams per cubic centimeter. So convert the grams per cubic centimeters to kilograms over cubic meters. Guys, yung technique ko dito is diretso na. Okay, take note. Dapat memorize nyo na to. Okay, 1 gram over cubic centimeters is equal to 1,000 kilogram over cubic meters. Okay, para diretso na yung ating conversion. Recall guys, this is your SI units for density. Okay, times G 9.8 m over S squared times height times R. Yung hinahanap natin. Divide by 2. Shift solving guys, you will get R is equal to 3.35 times 10 to the negative 4 meters. Letter C. Guys, I hope you got the correct answer. Okay, now let's proceed to the next topic, guys. So here we have our topic 6, properties of simple mixture. So you have here 6 items, okay, from number 46 to number 51. So let's see, guys, okay? And number 46, which is the following, is true at extremely high temperatures. A, the chemical potential of solid, liquid, and gas are all equal. B, the chemical potential of the gas is the lowest. C, solid is the most stable phase. D, none of the above. Oh, guys, madali lang to, di ba? Okay, at extremely high temperatures, okay? Recall our graph for our chemical potential. Again, the y-axis refers to the chemical potential, tapos temperature naman sa x-axis. Now, guys, among solid, liquid, gas, sino ang may lowest chemical potential? Syempre, guys, si gas, di ba? Diba? Recall guys, as you increase the temperature, the chemical potential of the gas decreases, right? Imagine guys, diba? If you increase the temperature, the gas molecules will move much faster. So there is less tendency for them to react. Okay, since there is a less tendency for them to react, okay na sila. Okay, that's why they have a low chemical potential. They are stable in that phase. Okay, and it is also because of their higher entropy. Since they have a higher entropy, guys, ayaw na nila mag-react with one another. They are busy moving around, diba? Because of the high kinetic energy due to the high temperature. So again, your gas molecules is stable. Therefore, it has a low chemical potential. Therefore, the answer for number 46 is letter B. Letter E is obviously wrong, diba? The chemical potential of solid, liquid, and gas are all equal. Guys, hindi yan, diba? Guys, curious lang, kailan kaya nagiging equal ang chemical potential of solid, liquid, and gas? Guys, nagiging equal ang kanilang chemical potentials at the triple point. Okay, at the triple point. Next, solid is the most stable phase. Guys, that is wrong. Bakit? Okay, at extremely high temperatures, okay, let's increase the temperature for solid. Diba ito yung region for solid, guys? Ayan. Okay, between solid, liquid, and gas, solids have the highest chemical potential. Okay? Oh, guys, bakit? Because the solid molecules are much closer to one another. Okay? So if they're closer to one another compared to the liquid molecules and compared to the gas molecules, then they will interact more, right? Compared to the liquid molecules and compared to the gas molecules. Therefore, they are more unstable and they have a high chemical potential. Okay? They have a greater tendency to react or change phase. Okay? Or change phase. Okay? Next, number 47. Which of the following is true? Okay, guys, galing lang sa PD natin, tama? So similar lang to sa PD natin, guys. A, for temperatures less than the boiling point, the solid phase is the most stable. Guys, alam natin na mali yan, diba? For temperatures less than the boiling point, guys, dapat si liquid yung most stable, tama? Sino yung between freezing and boiling points? Recall your heating curve of water, diba? Si liquid. So guys, letter A is wrong. Next, letter B, for temperatures greater than the freezing point, the solid phase is the most stable point. Guys, if your temperature is now greater than the freezing point, what happens to your solid? Your solid melts, tama? Tama? Again, at the temperature higher than the freezing point, let's say 1 degree Celsius, diba? Again, recall that the melting point of ice is 0 degrees Celsius. So, the most stable above the freezing point is still liquid. Therefore, letter B is false. Next, letter D naman tayo, guys. For temperatures between the freezing and boiling points, the liquid potential is the greatest. Mali. Bakit, guys? Between the freezing and boiling points, ano nag-exist na state? Liquid, diba? That's why if the liquid is the most stable phase between the freezing and boiling points, guys, okay, therefore it must have the least liquid potential or least chemical potential. That's why for number 47, the correct answer is letter C. So again, these are the reasons, guys. Take note. Ayan. Again, for letter C, guys, between the freezing and boiling points, liquid is the most stable and has the lowest potential energy. So guys, kung makalimutan nyo man, tandaan nyo lang ang heating curve of water. This dapat memorize yan, ha? Again, dapat memorize ang heating curve of water. Next, number 48. Which of the following is true for ideal solutions? Okay, again, for ideal solutions, recall, guys, okay, the interactions between components A and B in your ideal solution, okay, is equal to the strength of the interactions between the A components and the B components. Gets, guys? Again, the strength of A-B interactions is just equal to the strength of your AA and BB interactions. Okay, so again, that is the cause of ideal solutions. Ma'am, ano ulit yung non-ideal solutions? Tandaan, guys. For example, yung example natin sa ating crash course on phase equilibrium, diba? Or example, there is hexane and ethanol, diba? Guys, they have different IMFAs, diba? So the strength of the interaction between hexane and ethanol is weaker compared to the individual interactions of hexane to another hexane molecule and ethanol to another ethanol molecule, diba? That's why in this case you have a non-ideal solution, diba? Okay. So with that in mind, guys, okay, so ito yung pagpipilian natin. 1, delta mix H is equal to 0. 2, delta mix S is equal to 0. 3, P solution is just equal to the summation of the partial pressures of your solution, of your components of your solution. 4, delta mix G is equal to negative R times the summation of N, I, L, N, X, I. So guys, ang tama lang dito is 1 and 3. Again, for ideal solutions, ito lang to 1 and 3. Okay? Tingnan natin, guys. Ayan. Okay, so for 1, okay, we know that the delta mix H is equal to 0 for an ideal solutions. Okay? Because the interactions between unlike molecules such as A and B are the same as those between like molecules. So guys, wala kang enthalpy na ma-absorb, wala ka ding enthalpy na ma-release. Okay? So delta mix H upon mixing is equal to 0. Next, delta mix S is equal to 0. That is false for ideal solutions. Guys, we know that when we mix two substances spontaneously, there is always an increase in entropy due to the increased disorder. Next, puntahan natin si 3, guys. P solution is equal to the individual pressures of your components of your solutions. Okay, guys, so this is true. Okay, again, this is true. Okay? And this gives us Raoult's law for ideal solutions. Okay? So parang similar lang din siya for Dalton's law. Diba? Parang similar lang din siya ng equation sa Dalton's law. Okay? Lastly, 4, delta mix G is equal to negative R times N, I, L, N, X, I. Guys, that is false because the correct equation is delta mix G is equal to negative RP times the summation of N, I, L, N, X, I. Okay? Ayan. Okay, recall, guys, your Ni here is just NP, total number of moles, times the mole fraction of the component I. Okay? Okay. Next, number 49. Davis equation is the most appropriate equation to use to determine the activity coefficient when Okay. A, the activity is greater than 1. B, the activity is less than 0.1. C, ionic strength greater than 0.1. D, ionic strength is less than 0.01. So guys, in order to determine the activity coefficient, we have to use the Debye-Huckel limiting law, extend the Debye-Huckel law, and the Davies equation. So guys, kung sino man ang gagamitin natin dyan, it depends on the ionic strength. So recall this table, guys. Diba? If ionic strength is greater than 0.1, then the best equation to use is the Davies equation. That's why for number 49, the answer is letter C. Okay? Very easy, guys, right? Kaya. Okay. Next, number 50. What is the boiling point of a 3.5% aqueous NaCl solution? So guys, these are your choices. Ano kayang sagot nyo? Okay. Recall, guys, that for NaCl, this is an electrolyte solution. Tama? Again, you have an electrolyte solution. Guys, ito yung tandaan nyo. Kapag may electrolyte solution kayo, okay, di ba mag-dissociate yan in solution? Guys, okay, this results in a non-ideal solution. Ma'am, bakit? Because guys, your interactions between Na and Cl are electrostatic interactions. And guys, electrostatic interactions, okay, will arise in non-ideal solutions. Okay? Ma'am, bakit? Kasi guys, yung interactions na yan are significant, okay? Which will affect the interactions of individual molecules or the interactions between unlike molecules, okay? So recall, this is the dissociation of NaCl in water. Ma'am, bakit water agad? Guys, we have an aqueous NaCl solution. Again, guys, kasi having aqueous NaCl in water. So we have formed here Na plus Cl minus. So unang gagawin natin, guys, is to determine the Van Hoff factor I before we determine the boiling point. So to get the Van Hoff factor I, alpha, the degree of dissociation, is equal to I minus 1 over V minus 1, where V is the number of ionic species. So substitute lang, guys. We know that NaCl will fully dissociate in water, right? So its degree of dissociation is 1. 1 is equal to I minus 1 over 2 minus 1, where V is equal to 2 because you have two ions, Na plus and Cl minus. Solving, guys, I is equal to 2. Okay, now we are ready to determine the boiling point. So, paano natin kukunin ang boiling point? Through the boiling point elevation equation. Okay, so before we do that, guys, determine or simplify muna natin ang ating molality equation. Okay? Okay, how do we get the molality equation? It is using this concentration here. Sabi dito, we have 3.5% aqueous solution. So, guys, gawin natin yan. 3.5 grams NaCl, that is just equal to 3.5 grams NaCl over 100 grams solution. Diba, guys? Again, 3.5% aqueous NaCl solution is just equal to 3.5 grams NaCl over 100 grams solution. Now, guys, recall, for molality, our unit is mole solute over kilogram solvent. Tama? So, ito, so guys, dapat nasa denominator niya ay in terms of kilogram solvent. Kaso nga lang, ang meron sa denominator natin ay 100 gram solution. So, how do we determine the kilogram solvent? So guys, 100 gram solution minus 3.5 grams NaCl, which is your solute. So again, gram solution minus gram solute, which is NaCl, is just equal to the grams of the solvent. Okay? So 100 minus 3.5, you get 96.5 grams of water, your solvent. Tapos convert the grams of water to kilograms of water, okay? Where 1 kilogram is equal to 1,000 grams. Okay? So again, this is your expression for molality. Isa-substitute natin yan later. Okay? Okay, so of course guys, tandaan, syempre guys, hindi pa tayo tapos dito, diba? So ang gagawin, sa 3.5 grams, convert pa natin to moles. Okay? So let's do that later, guys. Ayan. So again, to get the boiling point, we use this equation here. Delta TB is equal to IKBM, where delta TB is equal to TB minus TB naught. Okay, recall guys, yung boiling point ng solution nyo will always be higher than the boiling point of the pure solvent, which in this case is water. Okay, because the solute, okay, hinders the boiling of your particles. That's why your solution would require a higher boiling point in order for the liquid to vaporize. Okay, so delta TB is equal to TB minus TB naught is equal to IKBM. Okay. Ano si KB? So guys, again, you have an aqueous NaCl solution, so you know that your solvent is water. So yung gagamitin nyo na KBI, 0.512 degrees Celsius over molal. Okay, so let's substitute. Okay, TB is equal to IKBM. Again, this whole expression here is IKBM. I is 2 times KB, 0.512 degrees Celsius over molal, times your molality here. So again, 3.5 grams, convert grams to moles, where mass divided by molar mass lang ang gagawin natin, di ba? NaCl, the molar mass of NaCl is 58.4 grams over mole, di ba?